Okay guys, so we're looking at section 5.4 in our student journal. This is on page 140. So I just mentioned that extraneous solution that came about on example 3 in our warm-ups. So here's the formal definition of extraneous solutions. These are solutions found by raising each side of an equation to the same power that are not solutions to the original equation. So we get these solutions, like in number 3 in our warm-ups, we subtracted 4, then we squared both sides, but when we plugged it back in, it didn't really work. So therefore, it was an extraneous solution. So when we get solutions, you must check each apparent solution for these, because they do occur quite often that we get this extraneous solution. When we're going to solve a radical equation, this is our whole goal for the day, we follow these steps. First of all, if you can, and if it's necessary, you want to isolate the radical on one side of the equation. The reason for that is because it's easy to square a radical. The radical just goes away. So if we can get that isolation of that radical, it's going to make the problem easier. We raise each side of the equation to the same exponent to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. So if I have a square root, I'm going to square both sides. If I'd had a cube root, I'd have to cube both sides. After we get one of these, then we just solve the resulting equation using techniques we've learned. And then we just have to check it. We have to check it to make sure we don't have those extraneous solutions. So let's look at this first example in that space that you have. X plus 1 equals the square root of 7x plus 15. We check to make sure the radical is isolated, and it is. So what are we going to do to both sides to eliminate the radical? McKenna, what are we going to do? What's the opposite of a square root? Square it, right? To get rid of the radical, you just square it. Okay, so I'm going to square both sides. So I'm going to square this side, and I'm going to square this side. Squaring this side is easy because if I square a radical, the radical just disappears. Squaring this side is a little more difficult. If I have x plus 1 squared, I cannot just square the x and square the 1. This is what we call a binomial. It's two terms. So I have to think of it as x plus 1 times x plus 1. Can we do that? What's x times x? Everybody? And then the outers are going to give us an x and the inners give us an x. So what's that? And then the 1 times the 1 is just 1. So here's what we got. Now, look back at step 2. We did this, raise each side of the equation to the same exponent to eliminate the radical. Okay, so now we have a quadratic equation. We always have to get these set equal to 0. So I'm going to subtract 7x, and I'm going to subtract 15. So now I have x squared minus 5x minus 14. When we have a quadratic, we know we can use the quadratic formula, completing the square, or factoring. We hope we can factor. That's the easiest way. Are there numbers that multiply to be 14 and subtract to be 5? What are they? 7 and 2. So we're going to set up our double parentheses. X, 7, 2, minus, plus. And our solutions are x equals 7 and negative 2. Now, I want to check to see if both of these are solutions because it could be extraneous. Plug in 7. 7 plus 1 is 8. Plug in 7 here. 7 times 7 is 49 plus 15 is 64. Square root of 64, 8. Okay, so that worked. Plug in negative 2. Negative 2 plus 1 is negative 1. 7 times negative 2 is going to be negative 14, plus 15 is 1. Square root of 1 is 1. Negative 1 does not equal 1, so therefore that does not work. Now, if I'm not sure about that, here's what I would do. If I thought, well, I don't understand why there's one solution. Maybe you're thinking about that. Well, we could always graph it. Here's the linear function, and then we're going to see the square root function. Can you see how there's only one solution right there? And if I wanted to check it, I could find that one solution. Just get up there kind of close to it. Doesn't even have to be that close. Hit enter 3 times, and it tells me the solution is 7. Okay? So it's nice to have these 2 ways of solving, graphically and analytically. Analytically just means algebra. All right, I want you guys to do example 2 now, either on your own or with your partner. Taylor, what do you say?
Well, I'm not totally done, but just want me to tell you how I did it?
Yeah.
Okay, so square both sides from that. So you get x equals 9, but then I'm going to check it.
So square root of 9 is what?
3.
Plus 5?
Okay.
Not 2, right?
Right.
So therefore, what do we know about this? Doesn't work, so therefore, what's our answer, everybody? No solution. Sometimes that can be hard to understand. So here's the square root of x plus 5. That's going to be that square root function shifted up 5 units. Here's y equals 2. See how they're never going to meet? So therefore, there's not going to be any x that's going to make these 2 equal to one another. So it's no solution. All right. Let's come over here to the next page, 141. We're only going to be doing a few of these. We're definitely not doing all. We're just going to be doing 4 of these. I want us to look at number 2 to start with. So on this one, we have the cube root. So how do we undo the cube root? Cube it. So we're going to cube both sides. Now, remember on the other problems, when we had the square root and we had a negative, we always got that no solution. Okay, but is that going to be the case here? I don't know. Let's see. Cube it, we get 5x plus 1 equals negative 64. Subtract 1. 5x equals negative 65. Divide by 5. 6 divided by 5 is 1, with 1 left over. 15 divided by 5 is 13, negative 13. If I plug it in, 5 times negative 13 is negative 65, plus 1 is negative 64. Is the cube root of negative 64 negative 4? Watch if I go to my calculator. I go to math, I go down to cube root. The cube root of negative 64 is negative 4. Okay? That's because a negative times negative times negative gives us that. So this is going to be the solution. So it's okay for a cube root to equal a negative, but it would not have been okay to have this problem. What's the answer to this going to be? No solution. And that's because the domain of this is going to be from 0 to infinity. So it definitely is never going to equal negative 4 if we're only going to be plugging in numbers from 0 to infinity. All right, let's go down to number 3. This one's a little tougher. Carter, what would you do first?
Probably, make each side equal.
Already? I would just, you want to isolate that radical.
Yeah.
So what do you want to do?
Times everything by 4.
Okay, we can do that. So if I multiply this term by 4, I'm going to get the 4th root of 2x. Multiply this by 4, I'm going to get 24. Multiply this by 4, I'm going to get 40.
And then minus 24.
Okay, so the 4th root of 2x equals 16.
And
to the fourth power. So the fourth root of that's just going to be 2x. 16 to the fourth is a huge number. 65536. I'm going to go ahead and divide that by 2. Now, that number seems really large, but that's okay to have that large of a number. See, we already know the fourth root of this number. Remember, what's the fourth root of this number going to have to be? 16 to the fourth gave it to us. So if I plug it back in, this number times 2 gives me this number. And what's the fourth root of this number? 16. 1/4 of 16 is 4, plus 6 is 10. So just because we got that large of a number, that doesn't mean it's not a solution. It actually is. Now that would be difficult to do on the calculator. What would I have to set my window to be able to see that solution? Yeah, my X max is going to have to be at least like 33,000 to be able to see it. So it's probably not worth checking that. We're just going to have to go with it. All right, number 7. Okay, so we look and we see if we can isolate the radical. To isolate the radical, we'd have to divide by 4. Why might that not be the best way to go? I'm going to end up with some ugly fractions to work with over here, so I'm not going to isolate that radical. I'm just going to go ahead and square both sides. Because this is multiplication, I do not have to FOIL this out. This is multiplication. I just square the 4 and square the radical. So what am I going to get then? 16 parentheses x plus 1. But this one is not multiplication, it's addition. So I am going to have to think of squaring that out as x plus 1 times x plus 1. What is that going to be? Jesse, what would that end up being?
It would be x to the x plus.
Do this times this.
X plus 2x. X squared plus 2x plus. Sorry, plus 1.
Plus 1, right. Okay. So that's what we get. So now we want to go ahead and distribute the 16. Kat, what do I want to get it set equal to solve a quadratic? Yep, get it set equal to 0. So do this and this. Okay, are there numbers that multiply to be 15 and subtract to be 14? What are they? 15 and 1. So I'm going to go ahead and factor. And I get 2 solutions, 15 and 1. I could plug those in to check. I can also do this though, guys. Now I think I should have 2 solutions of 15 and 1. Ooh, is 1 a solution? Is 1 a solution? No. If I want to check. Oh, thank you. Even still, is -1 a solution? No, because they're not meeting right there. So I'm going to check the 15. I'm going to extend the window out. Let's see if they meet there. Oh, I need to go higher too. Maybe. Might have been easier just to plug it in. You never know for sure though. Ooh, and -1 may be a solution now. What I'm going to have to do is look at my table of values. And also I'm going to have to think about this. That's okay, isn't it? Negative 1 actually is a solution. And this is showing us why we have to be careful when we use a graphing method. See how if I plug in negative 1 into the first one, we get 0. Plug negative 1 into the second one, we get a 0. So that is a solution. And then I can also check the 15. See if I get the same answers. Yep, that's also a solution. So that's another way to check rather than just substituting in. But don't just go with that graph, because let me go back to that again. See how when we look at the graph, it looks like it's not a solution, but it actually is. It's just that the graph is not connected the way it should be. Can you think about graphing this on your own? What is this? A shift to the what? To the left one. So here would have been our vertex, but now it's a shift to the left one, so it's not really showing us that whole entire graph. Okay, let's go to this last one we have, number 10. All right, so for number 10, I'm going to have to use this space up here. This one takes a lot of space. Square root of x plus 7 plus 2 equals square root of 3 minus x. We're going to need a lot of space. And here's the reason why. It is impossible for me to isolate both of these radicals. Like I have this one isolated, but if I subtract 2, I can isolate this one, but then that one's not isolated. So it's impossible for me to do both. So I'm just going to have to leave it as it is and make sure that I'm careful when I square both sides. When I square this side, it's pretty easy to do. So this is just going to be 3 minus x. This one, when I square it though, this is a binomial. So I have to think of it as radical x plus 7 plus 2 times radical x plus 7 plus 2. Watch how I multiply this out. In other words, square it. This times this is just x plus 7. When I multiply these, I get 2 radical x plus 7. When I multiply these, I get 2 radical x plus 7. So altogether, how many do we have? We have 2 radical x plus 7 plus another 2 radical x plus 7. So what is that? 4 radical x plus 7. Then I have to multiply that times that, which is just 4. So this is what I have now. So I've got x plus 11 plus 4 radical x plus 7 equals 3 minus x. What should we do now? Isolate the radical, right? So I want to get this radical term by itself. So what do I have to get rid of then? Yep, I got to get rid of this x. And I have to get rid of this 11. I can't get rid of the 4. I can't subtract 4 because it's multiplying by that radical x plus 7. That's all I can do right now. So I have 4 radical x plus 7 equals negative 2x minus 8. At this point, there are a couple of different ways to go, and I don't care which way we go with it. Kaylee, what would you do next? Okay, so if I divide this side by 4, this term by 4, and that term by 4, every term, this is a term by itself because it's multiplication. So that's going to give me, I'm going to use this space, radical x plus 7 equals negative 1/2 x minus 2. What do we have to do now? Square both sides, right? So I have to square this side, and I have to square this side. This side is easy to square. The square root's just going to go away. This side is more complicated because I have to do negative 1/2 x minus 2, negative 1/2 x minus 2. So when I multiply this, I do this times this. What's negative 1/2 times negative 1/2, you guys? 1/4 x squared. The outers, negative 1/2 times negative 2, what is that? And negative times negative is a positive. What is it? Positive 1x. The inners. Negative 2 times negative 1/2. What is it? Positive 1x. What's negative 2 times negative 2? Negative 2 times negative 2, guys? Plus 4. All right. Getting this a little more simplified. Okay, now we have a couple of options, a couple of ways we could go. Tori, what do you want to do?
Take all on one side.
Okay, so I'm going to subtract this over. So now I have 0 equals 1/4 x squared plus x minus 3. What do we do now? Everybody, what's a good choice? Multiply by 4 is what I heard some people say, and that's the best option. So now I have 0 equals x squared plus 4x minus 12. Finally, something that looks easy to solve. What are numbers that multiply to be 12 and subtract to be 4? Yes, Karen. So how's a factor, Karen?
X plus 6 and x minus 2.
Good. So then our solutions are negative 6 and positive 2. I'm going to go back to that original. I got to plug those in. Negative 6 plus 7 is 1. Square root of 1 is 1 plus 2 is 3. Plugging it in here, 3 minus negative 6 is 9. Square root of 9 is 3. That one checked out. 2 plus 7 is 9. Square root is 3 plus 2 is 5. And then 3 minus 2, no, that's 1. Square root of 1 is 1. That one does not work. Our only solution is negative 6. All right? So what's our goal on these? To do what? Get that radical what? Isolated. Get it by itself, and then just go through it.